Hi guys, this is Miss May. I just wanted to make this video to review the last 3 days of notes that we went over in class last week before leaving on this break. So I wanted to make sure that these are fresh in your head. I'm going to go quickly because this video only lets me record for 5 minutes. So I'm going to go over just the essentials so that you guys have a good run through. If you want to get a copy of the notes, you can go under WITS. Under the documents, you have to go to BE May, Unit 9, and they're right here, notes, keys, days 1 through 5. Okay, so here they are. I'm going to highlight as we go just things that I want you guys to remember from each day. So day 1, we did the square root function, graphing, and talking about domain and range, as well as the cube root function. When you graph a square root function, remember it looks like what you see in front of the page here. It has a distinct starting point. And the reason for that is because when you went into your table, you are unable to square root negative numbers. So there was something that said error on the table. And we had to graph starting with the first point after error, which if it hasn't moved or been transformed left, right, up, or down, that first point is going to be 0, 0. So you can see that here. And then you get some of the nice points so that you can see that it goes in this shape right here out towards the right. These are your domains and ranges. From left to right is domain. Remember, from low to high would be your range. Okay, moving on to your cube root function. Just kidding. These are the transformations. So same as they always were. If it's inside, it's moving to the left or right. Remember, plus is left, right's minus. So this would be an example of it moving left 5. This would be right 5. If it's plus on the outside or minus on the outside, it's up or down. So this example would be down 3. You can go ahead and pay attention to these examples and look how they change your domain or your range. If it moves left, then your domain goes left 5 minus 5 to infinity. If it moves down, that will change your range. It will go lower. So it's going from negative 3 to infinity. And again, if you put those in your calculators, that will help you to see it if you need a picture. Okay, moving right along. These are writing functions. The cube root function was much different. Okay, the rule for graphing that is that it has to look like an S. It has to be in this kind of shape. And when you go ahead and graph this, when you're using your table, remember to go into your y equals, you hit the math button to get your cube root function. It's math, and then it should be one of those options listed. It's either number 3 or 4. That's the cube root function. You need to plug that in there, and then cube root of x. When you go into your table, you look for 3 points that are next to each other. Those are your middle points. You're going to see those right here. They kind of create like a line. And then you need to go 1 point below so that you have that tail of the S, and 1 point above. The domain and range for cube root function is always all reals because you have an arrow from left to right and low to high. Moving down to the transformations, those are going to be the same as square roots. I'm not going to cover those. Day 2 is graphing exponentials. So when you go ahead and graph an exponential, you want to make sure that, I'm going to skip actually down to where we actually did graph ourselves. You want to make sure that you collect 2 decimals from the table. If it's a growth, so if the number here is actually greater than 1, it's going to be a growth. It'll look like this, kind of like going up a roller coaster. So if it's a growth, your decimals are going to be at the top. You're going to go small, 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 and then it's going to go really high really quickly. Look at how your y values change here. They're all being multiplied by 2. That's what makes it an exponential. They get multiplied by the same number. And make sure when you graph that you do not touch that bottom line here. So I'm going to show you the bottom line in red as best as I can. Okay. It never touches that bottom line, wherever that bottom line may be. If it's been shifted, look over here on number 2. If it's been shifted down 1, the bottom line is negative 1. So it hovers right over it without touching and then shoots up. Your domain for those, since it's an arrow from the left to the right, is all reals. Your range, remember, since it doesn't touch that bottom line, is going to be from 0 with a parenthesis to infinity. Okay, if it's an exponential decay, it's like it's going down the roller coaster. If you pay attention to these y values here in the table, they're going down. It looks like they're all being divided by 2, or what we always do in exponentials is we say, what are they being multiplied by? So they're being multiplied by 1/2. Okay, that looks like you're starting high on top of the roller coaster and going down. Remember, never touching that bottom line when you do that. This shows a shift left because it's a plus 3. We consider that the inside when it's with the exponential. And then up here, minus 1. On the outside, that was down 1. Okay, so your transformations again are the same. So the rules are up here. You must graph a few decimals and get close to the bottom, but do not touch. And then day 3, there's more transformations. I'm not going to cover those. And you guys are actually really good at those. If you want to take a closer look at them, look at the answer key, okay? Day 3, we were writing equations. When you write an equation in exponential, you need to write it in y equals a times b to the x format. This is the format where you need to find your a and your b. So down here, we discussed if this is an equation and 0.01 was your a and 2 was your b, 0.01 is your starting amount. If you think back to that penny situation, it was the amount that the sun started with. He started with a penny, so that's your a value. It's your starting amount. It's also your y-intercept. I had you guys writing that down here. It's not on my answer key, but it's your y-intercept when x is equal to 0. Okay? Your b is your growth factor. It's what you multiply by. So this 2 is what you multiplied each of those coins by to get to that 10 million mark. You kept timesing by 2, timesing by 2. So the b is your growth factor. Sometimes it's called a common ratio. It's what you multiply your y's by. Okay? So then we were deciding whether something was either a linear or an exponential. If it's a linear, it adds by the same amount. If it's exponential, it multiplies. And we were writing equations from there. Take a look at this because I think it's about to cut me off this video. So I'm going to stop here. But remember, taking a look, if you're writing an exponential, you need to find whatever it's being multiplied by. And you need to find your starting amount when x is equal to 0. So this was your a value when x is equal to 0. The 3 goes here. And I got that right from the table. When my x value is equal to 0. And then whatever you're multiplying by, that's what goes in your b value. That's how you write